All right, this is lesson 2.8, proportions and similar figures. Go ahead and put your name on that page and let's get started. Okay, so our first slide are the objectives of this lesson. So our objectives are to find missing lengths in similar figures and to use similar figures when measuring indirectly. So down below, we've got two images of two sailboats, and they're exactly the same shape, but they're not necessarily the same size. So as you can see, we've got 12 feet for the height of the bigger sailboat and 4 feet for the smaller one. And then the width of the sailboat is 9 feet for the larger one, and we don't know what the width is going to be. And that's exactly what this lesson is all about. It's finding missing lengths for similar figures. And a similar figure has the same shape, but not necessarily the same size. Okay, similar figures. So the symbol, that little squiggly line, means it's similar to. So in the diagram, ABC is similar to FGH. And when two figures are similar, angles are congruent, and sides are proportional. Okay? Now, you might be wondering, well, what does that mean? Okay? So, if we were to take the distance between F and G, that's this distance right here. Okay? If we were to take that distance and we were to compare it to the distance of the smaller one, okay? So the distance of the smaller triangle that represents that side would be AB. Okay? Now, since they are similar, we can say that that is equal to the distance of any other side compared to the same side of the smaller triangle. So let's take FH, which is 15, and the corresponding side to FH would be AC, which is 10. Okay? Now, all we have to do is plug those in and see if it actually works. So FG in our image was 12. So 12 over, and then AB was 8, equals, does that equal FH, which is 15, over AC, which is 10? Okay, now all we have to do is cross multiply. So 12 times 10 becomes 120. And then 15 times 8. 15 times 8 will give us 40. 8 times 1 is 8. Plus 4 will give us 12. So 120. So 120 equals 120. That is correct. Okay, and that works for any of the two sides. So we could have done FG over AB equals BC, or GH over BC. Okay, we could have used the bottom side of the triangle as well. So whenever you say it says that there are similar figures, all of the sides corresponding to the bigger and the smaller figure can be turned into proportions. Okay, and we'll do a lot more examples like this. I was just showing you an example. Okay, so now we've got to find a missing side, okay? And up in the top upper left corner, this is labeled problem 1. So in your homework, sometimes it'll say see problem 1, see problem 2, and these are examples that will help you with your homework. So if you're ever stumped in a homework problem, always go back to the notes and look at which problem it's referencing, okay? So in the diagram, ABC is similar to DEF, okay? That's what that squiggly line means, remember? And it's asking us to find what DE is. And that's this side right here. So that's what we're looking for, okay? What is DE? So we've got to find what that side is right there. So first, what you always want to do is write down a proportion of what's given. And I see that this side, BC, is given. And also EF is also given, okay? So what we can do is we can write BC over EF is equal to, now DE is what we want to find, okay? But DE was the smaller one, okay? So DE has to go on the bottom, okay? Because all the sides that are going to be, you could either have it on the top or the bottom, but it has to be consistent with the one that you set up. See how EF is from the smaller triangle? That means that DE would have to be on the bottom. And BC was from the larger triangle, then AB would have to be on the top. The reason we picked AB is because that one is the same, it corresponds similarly to ED or DE, okay? So AB over DE. Remember, each time you are writing a proportion, the two that are in the same fraction should be the ones that are corresponding with each other. So DE is the same side as AB, only different in the larger or the smaller figure, okay? So now all we do is plug in. So BC was 16, the distance between point B and point C. That's 16. The distance between E and F is 12. And that's going to be equal to the distance between A and B, which is 10, over, and then DE. That's what we're trying to find, okay? So DE we're going to treat as its own variable, so like X, okay? All right. Now we just cross multiply. Okay, so this is going to, the red portion is going to turn into 16 times DE is equal to, and then the yellow portion will be 120. We can divide both sides by 16, not 12, 16. Divide by 16. These will cancel, and we're going to be left with DE equals 120 divided by 16 gives us 7.5, which is A. Okay. So that's how you find the missing side of a similar figure, okay? You always set up a proportion, all right? And when you're setting up a proportion, remember, you want to use two sides that you already know. So the only two sides that we saw that were already filled in and corresponding were this 16 and this 12. So we knew that had to be the first part of our proportion. Okay? All right, so let's do the same thing for another missing side. So in this case, we want to find AC. AC is this bottom one right here. Okay, what is AC? And so in order to find that out, we have to first set up the proportion that we know, okay? And the one that we know is we still have this 16 and this 12. So that's still going to be our proportion. So we're going to set BC over EF equal to, now we get into the tricky part where what we don't know. So AC is part of the larger triangle, so that one has to go on the top. And the side that is corresponding to AC is this 18, or this DF of the smaller one, okay? Now all we do is we plug in. So BC is 16, EF is 12, AC we don't know, so we can either leave it as AC or change it to X, and DF will be 18. Now we just cross multiply. Okay, one of the crosses will be 16 times 18 equals 12 times X. Okay, and then this 16 times 18 becomes 288 equals 12x. We divide both sides by 12. And we're going to be left with 24 equals x. So AC equals 24 units. Okay, so as long as we're given 3 side lengths, we can figure out the fourth one, okay? All right, so again, similar figures. Guys, for these problems, we are always going to be setting up proportions. So whatever you see similar figures, or if you see that mark, remember, this means similar. So if it says two triangles are similar to each other, you're always going to use proportions, okay? So the sun's rays strike the building and the girl at the same angle, forming the two similar triangles shown, okay? Remember, it says similar. How tall is the building? So as you can see from the image, we've got X feet for the building. So that's what we're trying to figure out, okay? Now, the two sides that are given are these bottom sides, this 3 and this 15, all right? So let's start by using those to set up our proportion. So we know that the girl's shadow is 3 feet, and the shadow of the building is 15. Okay, now the girl's height is 5, and because it's the girl's height, we're gonna put it on the top, and then X is what we don't know. Okay, but remember, the girl, shadow, the girl, height, the building, shadow, and then the building height. Remember, it's very important which one goes on the top and which one goes on the bottom. That is the main purpose of all of these problems, is to get that set up correctly, okay? So if the girl's height is 3, the building's height is, or the girl's shadow is 3, the building's height is 15. If the girl's height is 5, what's the height of the building? All we need to do at this point is just cross multiply. So we're gonna do that 3 times X, and then the 5 times 15, and we're gonna get 5 times 15 equals 3x. 5 times 15 will give us 75 equals 3x. We can divide both sides by that 3 so that it leaves x alone, and dividing 75 by 3 will give us 25 equals x. So, how tall is the building? Building is 25 feet tall. Okay. All right, scale drawing. Scale drawing is a drawing that is similar to an actual object or place, okay? So scale drawings, for example, exist a lot with maps. So obviously, looking at this map, the distance between Turkey and Bulgaria is not this distance right here, okay? It is scaled down, okay? And that means that the distances here on the map are proportional, but they're not exact. So there must be what's called a scale, or a ratio of any length on the drawing to the actual length, okay? And that exists as well for blueprints. So you'll see a lot of maps, a lot of blueprints in the examples that we do, and I want you guys to think about any other scale drawings that where when you're drawing them, it's going to be a different image once you scale it, okay? So there's always a scale. So for example, in the blueprint, the living room, maybe in the blueprint is like, I don't know, 20 inches squared. A living room that's 20 inches squared would be absolutely tiny, okay? But what it does is there's always a scale. So it could be like 1 inch corresponds to like 7 feet. And that would make more sense, okay? Then you would have a larger living room, okay? And we'll do some problems involving that as well. All right, so scale drawings. Maps, what is the actual distance from Jacksonville to Orlando? Use the ruler to measure the distance from Jacksonville to Orlando on the map. All right, well, here's our scale over here on the left side, okay? And whenever you're given a scale, all you wanna do is just write it as a fraction. So it's 1 inch over 110 miles. And that will always be the left side of your proportion, because we know that. Okay, now the right side of our proportion, it gives us a ruler. So we're gonna know how many inches it is from Jacksonville to Orlando, and that will help us calculate how many miles it is, okay? So we already know that x is going to be the number of miles because that's what we're trying to figure out is the actual distance between Jacksonville and Orlando. And it's 1 inch, 1.4 inches. Okay, 1.4 inches. All I did there was I counted the amount of inches.
Good morning, Mavericks. If you have not done so, please take your...
You can just count the number of tally marks. So we got 1 inch right here, and then it was 1, 2, 3, 4, and an additional 4 inches to get to Orlando. Okay, so once we're here, same thing, guys. All we do is we cross multiply. Okay, so we're going to be left with x, because it's x times 1 inch, equals 1.4 times 110, which is 154. So x is in miles as well. All right. So it's 154 miles from Jacksonville to Orlando. Okay, using scale model. So scale model of a building is 6 inches tall. The scale of the model is 1 inch is compared to 50 feet. So again, guys, 1 inch over 50 feet. Remember, once we're given that scale, we always want to write that immediately as a proportion, okay? How tall is the actual building? So we're going to set this equal to, well, it told us that the scale portion of our building was 6 inches. So we're going to put 6 inches over, and then what we're trying to figure out is that x in feet, because we want to know the actual height of the building, the actual size of the building. All we do is we cross multiply, okay? And once we do that, it's going to be x equals 50 times 6, which is 300. So it's 300 feet. Okay, the building is 300 feet tall. All right, we've got some check yourself questions, so I want you guys to try these on your own to make sure that you can get those right. Here are the answers. And then I want you to exit using an exit ticket. So the scale of a map is 1 inch to 100 miles. Is the actual distance between the two towns 100 times the map distance between the two towns? Explain. And this one I put hint, think about the units. So the map is going to show, let's say the map showed that it was 3 inches between the two towns. 3 inches between two towns. Multiplying those 3 inches by 100 would give us 300. So do you think the actual distance between the two towns is 300 inches? No, it's not. Why? Because they changed units. So in your explanation, you should have had somewhere that scales can be with different units. Okay? So the distance is not 100 times the map distance. Okay? All this exit ticket wanted you to do was to recognize that scales do not have to be in the same units.